Hello everyone and welcome to this video channel of Science Class 8. In the previous video class we studied chapter number 11 that was force and pressure. Today also let's continue the same topic. Today let's study about the non-contact forces. Non-contact forces. In the non-contact forces, we can mention some of the examples like magnetic force, electrostatic force, and gravitational force. These are the examples of non-contact force. So magnetic force, say in a bar magnet, north pole of a bar magnet will attract south pole of another bar magnet. This is an example of magnetic force, that is non-contact force. And force exerted by a magnet on a piece of iron, that is also a non-contact force. Here, electrostatic force. Electrostatic force is also an example of non-contact force. Electrostatic force. Electrostatic force is the force. Say here we can see one activity. Take a plastic straw and cut it into nearly two equal pieces. Suspend one of the pieces from the edge of a table with the help of a piece of thread. Now hold the other piece of straw in your hand and rub its free end with a sheet of paper. Bring the rubbed end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. What do you observe? Next, rub the free end of the suspended piece of straw with a sheet of paper. And again bring the piece of straw that was rubbed earlier with paper near the free end of the suspended straw. What do you observe now? Here, figure number 11.11, let's see a straw rubbed with paper attracts another straw but repels it if it has also been rubbed with a sheet of paper. So here, a straw is said to have acquired electrostatic charge after it has been rubbed with a sheet of paper. Such a straw is an example of a charged body. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. The electrostatic force, therefore, is another example of a non-contact force. You will learn more about electric charges in chapter 15. Here, let's see gravitational force. You know that a coin or a pen falls to the ground when it slips off your hand. Leaves and fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? When the coin is held in your hand, it is at rest. As soon as it is released, it begins to move downwards. It is clear that the state of motion of the coin undergoes a change. Can this happen without a force acting on it? Which is this force? Next page, let's move. So, objects or things fall towards the earth because it pulls them. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all objects. The force of gravity acts on all of us all the time without our being aware of it. Water begins to flow downward the ground as soon as we open a tap. Water in rivers flows downward due to the force of gravity. Here, gravity is not a property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as the gravitational force. So, I will explain about this thing. Let's see non-contact force. Examples of non-contact force are, point number 1, magnetic force. Magnetic force. Magnetic force is also one example of non-contact force. And number two, electrostatic force. Electrostatic force. Electrostatic force. This is also one example of non-contact force. And point number 3, that was gravitational force. Gravitational force. Gravitational force. So these are the examples of non-contact force. Okay, now let's see pressure. We have learned in class 7 that strong winds during a storm or a cyclone can blow away even the rooftops. You also learned that winds and cyclones are caused by the differences in air pressure. Is there any relation between pressure and force? Let us find out. Try to push a nail into a wooden plank by its head. Did you succeed? Try now to push a nail by the pointed end. Figure 11.12, it is shown. Could you do it this time? So when we try to push a nail, the pointed end should be it's at the wooden flank, so it can penetrate easily because the area of contact is very small. Next point, let's see. Try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? So cutting vegetables with a sharp knife is easier because the area of contact is very small, whereas cutting by blunt end of the knife, it cannot be easier because the area of contact is much more. Do you get the feeling that the area over which the force is applied, for example, the pointed end of the nail, plays a role in making this task easier? The force acting on a unit area of a surface is called pressure. So now, what is pressure? Pressure is equal to force by area on which it acts. And at this stage, we consider only those forces which act perpendicular to the surface on which the pressure is to be computed. Next point, let's see. Here is a picture of girl. What she says, let's see. I now understand why potters place a round piece of cloth on their heads when they have to carry heavy loads. Here is figure. And by doing this, they increase the area of contact of the load with their head. So the pressure on their head is reduced and they find it easier to carry the load. So most of the porters, they carry loads on their heads. So they used to on their head, they use to rub a cloth on their head in order to carry the heavy loads. Round piece of cloth on their heads is there in order to carry this load. So a porter carrying a heavy load. Next point, let's see textbook page number 163. Note that the area is in the denominator in the above expression. So the smaller the area, larger the pressure on a surface for the same force. The area of the pointed end of this nail is much smaller than that of its head. The same force therefore produces a pressure sufficient to push the pointed end of the nail into the wooden flank. So can you explain now why soldier bags are provided with broad straps and not thin strap? And why the tools meant for cutting and pressing always have sharp edges? Do liquids and gases also exert pressure? Does it also depend on the area on which the force acts? Let us find out. So, pressure exerted by liquids and gases. Here is activity is there. Activity 11.1, let's see. Take a transparent glass tube or a plastic pipe. The length of the pipe or tube should be about 25 cm and its diameter should be 5 to 7.5 cm. Also take a piece of thin sheet of a good quality rubber, say a rubber balloon. Stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle, keeping it in a vertical position. Ask one of your friends to pour some water in the pipe. Thus the rubber sheet bulges out. And note also the height of the water column in the pipe. And pour some more water. Observe again the bulge in the rubber sheet and the height of the water column in the pipe. Repeat this process a few more times. Can you see any relation between the amount of the bulge in the rubber sheet and the height of the water column in the pipe? Here, this is just an activity. Here, it shows that pressure exerted by water at the bottom of the container depends on the height of its column. So, whenever the height of this column is high, then the pressure exerted at the bottom of this column will be greater. So next, let's see this activity 11.9. Take a plastic bottle. You can take a discarded water or soft drink bottle. Fix a cylindrical glass tube a few centimeters long near its bottom as shown in figure 11.15. You can do so by slightly heating one end of the glass tube and then quickly inserting it near the bottom of the bottle. Make sure that the water does not leak from the joint. If there is any leakage, seal it within with molten wax. Cover the mouth of the glass tube with a thin rubber sheet as you did in activity 11.8. Now fill the bottle up to half with water. What do you observe? Why does the rubber? Next page. Rubber sheet fixed to the glass tube bulges this time. Pour some more water in the bottle. Is there any change in the bulge of the rubber sheet? See here, figure number 11.15, you have seen a liquid exerts pressure on the walls of the container. So in this bottle, say water, that means liquid is filled, and at the bottom here is one rubber balloon. So whenever we put water inside this, then this balloon will bulge out. Based on this level of this water, the size That means the bulge out level of this balloon also will increase. It shows pressure is there. Next, let's see. Now, note that the rubber sheet has been fixed on the side of the container and not at the bottom. Thus, the bulging of the rubber sheet in this case indicate that water exerts pressure on the sides of the container. As well, let us investigate further. So, from this activity, we know that whenever we put liquid or water inside this bottle, then it gives pressure on the walls. So, the bulging out of this rubber balloon shows liquid exerts pressure at the wall of the container. Next, activity 10.11. Okay, next. Activity 11.10, let's see. Take an empty plastic bottle or a cylindrical container. You can take a used tin can or a used plastic bottle, drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Figure 11.16. Now fill the bottle with water. What do you observe? Do the different streams of water coming out of these holes fall at the same distance from the bottle? What does this indicate? So here, in this activity 11.10, 11.10, you have to take empty plastic bottle or cylindrical container, and you can take used tin or can. Then do this activity. Then you can find your observation. And in this activity, figure number 11.16, liquid exert equal pressure at the same depth. So here, holes are made in this bottle. When you put liquid, that means water, in the same pressure, water comes out from inside from this bottle. Next, can you now say that liquids exert pressure on the walls of the container? Do gases also exert pressure? Do they also exert pressure on the walls of their containers? Let us find out. Here, I have seen fountains of water coming out of the leaking joints or holes in pipes supplying water. Is it not due to the pressure exerted by water on the walls of the pipes? When you inflate a balloon, why do you have to close its mouth? What happens when you open the mouth of an inflated balloon? Suppose you have a balloon which has holes. Would you be able to inflate it? If not, why? Can we say that air exerts pressure in all directions? Yes, air also exerts pressure in all directions. Do you recall what happens to the air in the bicycle tube when it has a puncture? In the bicycle tube, if it is punctured, then the air inside it will come out. And do these observations suggest that air exerts pressure on the inner walls of an inflated balloon or a tube? Air also exerts pressure, so we find that gases too exert pressure on the walls of their container. So gas also, like the liquid, like water, they also exert pressure on the walls of their containers. Next, atmospheric pressure. Let's see, atmospheric pressure. You know that there is air all around us, This envelope of air is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. We know that pressure is force per unit area. This is the definition of pressure. If we imagine a unit area and a very long cylinder standing on it, filled with air, then the force of gravity on the air in this cylinder is the atmospheric pressure. Figure number 11.17. Atmospheric pressure is the force of gravity on air in a column of unit area. Here is the unit area. Atmospheric pressure is also force of gravity. And next, but how large or small is the atmospheric pressure? Let us get an idea about its magnitude. Activity 11.11, let's see. Take a good quality rubber sucker. It looks like a small rubber cup. Figure number 11.1, it is shown here. Press it hard on a smooth plain surface. Thus it sticks to the surface. Now try to pull it off the surface. Can you do it? You can see figure number 11.18. A rubber sucker pressed on a surface. So when you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of atmosphere acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. This activity might give you an idea about the magnitude of atmospheric pressure. In fact, it would not be possible for any human being to pull the sucker off the next page of the surface if there were no air at all between the sucker and the surface. Thus, it gives you an idea how large the atmospheric pressure is. So here, this is just the presentation about the pressure. So here again, if the area of my head were 15 centimeter into 15 centimeter, how much force air will exert on my head? This is need a calculation. The force due to air in a column of the height of the atmosphere and area 15 centimeter into 15 centimeter. That means figure 11.19. Figure 11.19 is shown here. Is nearly equal to the force of gravity on an object. So, on an object of mass 225 kg. So, 225 kg is equivalent to 2250 Newton. You know, Newton, it is the unit of force. The reason we are not crushed under this force of gravity is that the pressure inside our bodies is also equal to the atmospheric pressure. So, and balances the pressure from outside. So, this is say 15 centimeter into 15 centimeter. Say the force due to air in column of the height of atmosphere and area 15 centimeter into 15 centimeter is nearly equal to the force of gravity on an object of mass 225 kg. So 225 kg, and that is also equivalent to 2250 Newton. That is the force. So because of this, we are not crushed under this force of gravity. that is, the pressure inside our body is also equal to the atmospheric pressure and balances the pressure from outside. So this is the reason. Now here pressure of atmosphere on your head is shown here like this in this picture. And next, let's continue. Did you know? Let's see. Otto von Guericke, a German scientist of the 17th century, invented a foam to extract air out of a vessel. With the help of this foam, he demonstrated dramatically the force of the air pressure. He joined two hollow metallic hemispheres of 51 cm diameter each and foamed air out of them. Then he employed 8 horses on each hemisphere to pull them apart. Here figure number 11.20. So great is the force of air pressure that the hemispheres could not be pulled apart. You know, Otto von Guericke, that is a German scientist in the 17th century. He invented a foam to extract air out of a vessel. So with this help, with this foam, he demonstrated the force of the air pressure. Two hollow metallic hemispheres, here two hollow metallic hemispheres of 51 cm diameter are tight, and air inside it has taken off. Then eight forces are employed to pull apart this hemisphere. Then it cannot be pulled apart. That shows that air pressure is very strong. So forces pulling this hemisphere. So this shows that air pressure is so strong. Okay, now let's study some textual questions. Question number 1. Give 2 examples each of situations in which you push or pull to change the state of motion of object. So the answer for this question, you can say hitting the ball coming to us. And point number 2, kicking to football. That is also 1 point. And question number 2, give 2 examples of situations in which applied force causes a change in the shape of an object. So the answer for this question, say assessing a rubber ball. And point number 2, reshaping clay to make toys, you can say. And question number 3, fill in the blanks with the following statements. Question number 3a, to draw water from a well, we have to pull at the rope. And question number b, a charged body dash an uncharged body towards it. This should be attract. And number c, to move a loaded trolley, we have to dash it. Push. You have to push. The north pole of a magnet dash the north pole of another magnet. So this should be repels. Next page, let's see. Question number 4. An archer stretches her bow while taking aim at the target. She then releases the arrow, which begins to move towards the target. Based on this information, fill up the gaps in the following statements using the following terms. Muscular contact, non-contact, gravity, friction, shape, attraction. Number A. Question number A. To stretch the bow, the archer applies a force that causes a change in its. Here should be shape. The word should be shape. This one. Number B. The force applied by the archer to stretch the bow is an example of. This should be contact force. And number C. The type of force responsible for a change in the state of motion of the arrow is an example of a. This should be muscular force. And number D. While the arrow moves towards its target, the force acting on it are due to gravity, and that due to gas of air. So this should be friction. In the following situations, identify the agent exerting the force and the object on which it acts. State the effect of the force in each case. Number A, squeezing a piece of lemon between the fingers to extract its juice. So for this answer, you can say agent should be finger, and object is lemon, and effect in its effect juice is extracted by force. And number B, taking out paste from a toothpaste tube. So agent is finger, object is toothpaste tube, and effect toothpaste coming out by force. And number C, a load suspended from a spring while its other end is on a hook fixed to a wall. So the answer for this question number C, the agent is load and object is spring, and effect is expansion of spring. And number D, an athlete making a high jump to clear the bar at a certain height. Number D should be agent should be athlete, and object should be athlete's body, and effect is athlete jump over the bar. Next, question number 6, let's see. A blacksmith hammers a hot piece of iron while making a tool. How does the force due to hammering affect the piece of iron? So the answer for this question is the force due to hammering changes the shape of the piece of iron. And question number 7, an inflated balloon was pressed against a wall after it has been rubbed with a piece of synthetic cloth. It was found that the balloon sticks to the wall. What force might be responsible for the attraction between the balloon and the wall? So the answer for this question number 7 is the force which is responsible for the attraction between the ball and the wall is electrostatic force. When we rub the balloon by a synthetic cloth, it gets charged. When it is taken near the wall, it will get attracted towards the uncharged wall because of the electrostatic force, which is the force exerted by a charged body on another uncharged body. Next, question number 8, let's see. Name the force acting on a plastic bucket containing water held above ground level in your hand. Discuss why the forces acting on the bucket do not bring a change in its state of motion. So the answer for this question number 8, the force acting on a plastic bucket are gravitational force. It is acting toward downwards. And muscular force, it is applied by our hand to lift the bucket in upward direction. Next, question number 9, let's see. A rocket has been Question number 9. A rocket has been fired upwards to launch a satellite in its orbit. Name the two forces acting on the rocket immediately after leaving the launching pad. Question number 9. Answer. The two forces acting on the rocket immediately after leaving the launching pad are frictional force due to air and point number 2, force of gravity pulling in downward direction. And question number 10, when we press the bulb of a dropper with its nozzle keep in water, air in the dropper is seen to escape in the form of bubbles. Once we release the pressure on the bulb, water gets filled in the dropper. The rise of water in the dropper is due to number A, pressure of water, number B, gravity of the earth, number C, shape of rubber bulb, number D, atmospheric pressure. So the correct answer for this question number 10 is the rise of water in the dropper is due to this number, the atmospheric pressure. So with that, it comes to the end of this video class. In the next video class, I will bring you another topic. For today, let's stop here. Bye.